Hi, the idea of this clip is to provide you a brief overview of what Romer's endogenous growth model is about. You might have heard about the model maybe in a lecture in university, or just because it was in the news because of the Nobel Prize that Romer won for this model in 2018, and you might wonder what is the key idea of it. Okay, so what I will do in the first part of this clip is to provide you a simple sketch of the key sectors that are involved in the model and how they relate to each other. And then in the second part of the clip, I will look at the key implication for growth and what is the intuition driving the growth rate. Okay, so you might get a good overview just to understand what's going on in the model. Maybe that also helps you to understand if you have a class that involves the Roma model. Or maybe you think you understand the model quite well, but still there might be some details that help you to understand the relations between the sectors involved a bit better. So the basic outline of Romer's endogenous growth model is as follows. We have households here, okay? And these households, they consume a final good, which we call Y, okay? So Y goes basically here, and this is, so they consume the final good, okay? And households have two different types of labor. They have unskilled labor, which we call L, okay? And labor is only going into the final good sector. And on top of that, they have human capital, which, yeah, you can think of this is skilled labor, okay? And skilled labor, and this is important, skilled labor has two potential uses. They can work in the research and development sector, or they can decide to go into the final good sector, okay? Now, how is the final good produced? Generally, the final good uses different types of labor and something like capital, but capital will come in a very specific form, which is provided by the intermediate good sector, okay? So the intermediate good sector provides different types of capital, okay, or different varieties of capital. You can think of different types of machines. And in order to set up a machine or to build a machine, it needs a design. And the design comes from the research and development sector. Okay, you can think of the research and development sector of being an in-house part of the intermediate good sector, or being an independent sector that doesn't really matter so much. Okay, so let's now look at the production function in the final good sector. Okay, and this looks as follows. The final goods sector for producing has a production function that uses human capital with a marginal productivity of alpha and unskilled labor, okay, which has a marginal productivity of beta. So far so good. You may think this looks like a standard production function so far. Now we just add capital, and that's basically what we're doing, but this is where the action comes in, and it comes in from this sector, as you can already probably think of. Okay, so how does capital enter the model? So for capital, we said we have different varieties. Okay, so you can think of different firms that all of them are indexed with an index I, okay, and that index runs from 1 till A, okay, and A is basically the latest design, okay, so you can think of A as the number of as the capital stock, or as the knowledge stock in the economy, okay, and each of these firms I provides a capital good Xi. Okay, so you can think of them as being different firms. It can also be that one firm has two varieties, but let's think of different firms. Each of them provide a variety I, okay, that goes into the final production. Okay. and you sum up over all different varieties of these different capital goods. Okay, so you can think of now you have different machines that you can use in production, okay, that are not all the same. All of them come from the intermediate goods sector, and all of them initially require a certain design. Okay, how many different types of machines do we have? Well, that's exactly what is running from I equals 1 up to whatever is the knowledge stock of the economy. Okay, so that's up to A. And all of that enters with an exponent of which looks like a constant returns to scale production function, which basically it is, but it's not constant returns to scale in technology. Okay, but it's constant returns to scale in human capital, in labor, and in X. Okay, so the exponent here is 1 minus alpha minus beta. Okay, and this now is something that we should talk about. Okay, because what does this exponent mean? This exponent is basically an inverse measure of market power. So assume that alpha and beta are very high. Okay, so that the whole exponent here would be equal to 0 in the limiting case. Okay, what would that mean? If the exponent would be 0, that means it doesn't matter for the output production how many machines of a type I will use. Okay, because the exponent 0 makes everything into a 1 here. So I want to have as many different machines as I can. Okay, so I want to combine small amounts of very different machines. Okay, what does that mean? If I want to buy as a final good producer all different machines, then each machine producer has a lot of market power, okay, and has pricing power. And we have monopoly pricing here, so the machine is rented out to the final producer at a price Pi. Okay, so this is very important to remember, that 1 minus alpha minus beta is more or less inverse market power of intermediate goods firms. Okay, and in fact 1 divided by 1 minus alpha minus beta is actually the markup that this sector charges over its marginal costs, okay, for this price here. And what does this production function here mean? It means that a capital, different types of capital are not perfect substitutes. Yeah? That has a lot of implications that are very important that we won't go through, but it's important that you understand the basic idea that you have different types of machines, okay, and they're combined into this term, different types of machines that run from machine 1 to machine A. And how large is A? That depends on how many machines or designs for machines have been developed. So how is a machine being developed? That's where the key action also in the model takes place, and that's in the research and development sector. So we look at the change in A, that's like how many new designs are being developed, and this is in Roma's original paper modeled by the following function. Okay, that's a constant times human capital in this sector. So this sector needs engineers and stuff, okay, researchers, scientists, so human capital, and this human capital here builds on the existing stock of knowledge. So what does that mean? Sorry, by the way, so this should be delta A. Okay, so this is the change in designs. So in order to produce a new design, engineer or a skilled laborer, human capital kind of person, will take the stock of knowledge of the economy and interact with that in order to produce a new design. What does that mean? It means if the stock of knowledge is already high, then one unit of human capital will produce a higher output than if the stock of knowledge of the economy is low. Okay, so this is what we call standing on the shoulder of giants, meaning that the more knowledge is already there, the easier it is to develop a new design. But you can think of all kinds of different production functions here. Okay, so and that's very interesting. You can think of, is there, for example, is there returns to scale or diminishing returns to knowledge, to human capital in this sector, or is this guy, so the assumption in the Roma model is that this exponent here is 1, for example, right? But you can also think of other exponents here that would make all this analysis even richer, because here the whole production function in the research and development sector comes in, but we will stick to the very simple version here. So first, let's look at the missing links in the model, and then let's focus on what's the key interesting feature here. Okay. What you should also know is households don't need to consume the final good. Okay, so they can instead also forgo consumption. Okay, which means they're basically saving. Okay, and in this case, they could use output minus consumption here, and this would go into the intermediate goods sector. Then that's basically the change in the capital stock. Okay, that's capital accumulation. So we also have then an interest rate in the model, because the households can save here, can lend money, because the intermediate goods sector needs two things. It needs the design from the research and development sector, and it needs this capital, which is basically a transformation of unused final goods. And the designs it's getting from here at a price that we call PA. Okay. So PA also helps us to pin down the wage rate of the high-skilled laborers. Why? Because the wage of the high-skilled laborers will be, well, what is their marginal productivity in this sector? If you differentiate this function with respect to age, you're ending up with delta times A. Okay, that's the marginal productivity here. And that you have to multiply with the price of the design. So this would be the marginal product in terms of the number of designs, and that you would have to multiply with the price of each design, which is PA. Sorry, that's a bit messy here, but this is a detail which is not so important. Which of course now tells us, so this pins down the wage of the human capital in the R&D sector, but of course this has also to be equal to the wage here, right? In an equilibrium, the marginal skilled laborer is indifferent whether he or she goes to the research and development sector or she goes to the final goods production, right? As long as the wage rate would be higher here in the research and development sector, there would be laborers moving out of the final goods sector, and in here increasing the wage rate. So decreasing the wage rate if it was larger here to begin with. So in any meaningful equilibrium, the wage rate should be the same in both of these sectors for human capital. So they can, both of these sectors, and that's very essential to close the model, or to get the results that we want to have. It's essential that these sectors compete over human capital, basically. So two things are worth highlighting here in the Roma model, okay? The first one is this intermediate goods capital sector, which may look a little bit weird, okay? Which is a monopolistic sector. Why? Because you have fixed costs of entry in order to get a design and start producing in this sector. So you have monopolistic competition in this sector. And a very interesting production function here for the final goods sector, where different types of capital are not perfect substitutes, and which interestingly is a constant returns to scale production function with respect to human capital, labor, and each variety, so with respect to X, okay, each variety of capital goods. But, and this is the second very interesting feature of the Roma model, if you would double all production factors, if you would double H, human capital, labor L, X, and A, then you would more than double final output. So if you take into account the stock of technology, the stock of designs in the economy, the production function is no longer constant returns to scale, and that comes from the very specific feature of technology here in the model, because technology, the stock of designs in the economy, and that's why it's so important. That's why it's also so important to understand the production function here and what happens if we change that. This stock of technology has two uses, okay? So remember, and this is a very important difference to the Solar model, technological progress here does not just happen, but it happens on purpose. Why? Because firms innovate here in this intermediate goods sector. So on purpose, because they can temporarily make profits, they invest into research and development. Okay, and the result of the research and development sector has now two different uses. Okay, and that's the key crucial part. It has one use in final output production, and this use is exclusive. What does that mean? The monopoly firm can exclude another firm from using their design. Okay, so that's happening, for example, with patents. Okay, so in practice, of course, you can argue that's only for a limited number of time, but you can think of maybe patent protection is like forever. So on the one hand side, the technology, the stock of designs is excludable and rival. At least it's rival in the sense that it's embodied in this specific intermediate capital good. Okay, so this is the one use of the stock of technology, but on the other hand, technology is also here. Okay, and here it's non-rival, non-excludable. What does that mean? The firm produces a design that it uses for a capital good in production, but as an external effect, it creates or it increases the stock of knowledge in the whole economy, and therefore it makes it easier for an engineer or a scientist to develop a new design. And this is the great intellectual achievement of Romer, to model both of these uses or features of technology, non-rival use with external effects and an excludable use here in a general equilibrium model. So now you might have already some ideas what might drive growth in this model. Okay, one of them is if human capital is fixed, then the key feature will be how much human capital is available for the research and development sector. This will depend on the marginal productivity of human capital in the final goods sector. Okay, So if there's more human capital in the research and development sector available, then of course we have a higher increase here in the number of new designs. What is needed to turn those designs into intermediate goods, intermediate capital goods, we said earlier, is that households are willing to give up consumption currently in order to consume in the future. And this time preference of households is captured in the interest rate, which is the second source of growth in the model, because a high interest rate means that households are not very willing to give up consumption, meaning that the whole process of capital and knowledge accumulation will not proceed as quickly. The third and very interesting effect on growth will come from the structure of the intermediate goods sector here. Okay, we said that this sector has a certain market power that determines which prices this sector can charge the final goods sector for renting out the intermediate capital goods. And that's a markup, and that comes from this market power term, or the inverse market power term. Okay. Now let's think through what market power does. Market power lets us underuse our resources. Why? Because we can set the price here, because we're a monopolist, okay? So if we provide less quantity of X, that will mean a higher price for each Xi, okay? So this side of the model tells us that market power will lead to an underuse of resources and therefore to a lower output rate. However, there's a countervailing force here. Why? Because if we have market power as a monopolist in the intermediate goods sector, what incentive does that give to us? It gives an incentive to invest more into more designs. Where does that come from? Well, we can charge a higher price here, so we'll be able to buy a design at a higher price PA. That means we can increase the wage rate of human capital here in the R&D sector. And this R&D sector competes with the final goods sector here, where human capital has a certain marginal productivity alpha. Okay, so this is the positive side of market power in the model, that market power gives an incentive to invest more into the creation of new designs. A formal representation of what I just said can be found in equation 11 on page 92 of Romer's paper. This equation derives the steady state growth rate. Okay, and what do we see here? So growth is given basically as the product of the marginal product of human capital in the research and development sector in terms of new designs developed times the overall human capital in that research and development sector, so that we can rewrite in the following way. It's the marginal productivity of human capital in that sector again, times overall human capital in the economy, and now we have here this weird term on the right hand side of equation 11, which tells us how much incentive human capital has to not work in the research and development sector. So this term essentially reflects the incentives for human capital to work in the final goods sector, okay, and that's taken away from the overall, so that has a negative effect on the steady state growth rate. We see here the real interest rate, so a higher real interest rate means less growth. That reflects, as we said, that higher interest rate means that it's more costly for the intermediate goods sector to get the savings of the household, right? So that's what we said before. And then we have this weird term with respect to market power, okay, and that's more tricky to interpret.
Well, how does now the growth rate depend on market power? For alpha, you can derive, for both parameters, you can derive how the function depends on these parameters by taking the first derivative. It's not super clear. You would see that here that for alpha, the derivative is always positive. What does that mean? A higher alpha would always make this weird term higher, so a higher alpha would always lower growth, whereas the picture is a little bit less clear for beta. So whenever you have such a situation where you're not completely sure about the effect of a certain parameter in an equation, it generally makes sense to maybe plot the implied values of your dependent variable for the relevant parameter space of your parameters of interest. And the good news for you is that I already did that for you. So this graph shows you the implication for growth coming from this weird fraction on the right-hand side of the last equation. So A is alpha. Remember that alpha is the marginal product to human capital, the marginal product to skilled labor in the final goods sector. So moving here to the right means a higher return to human capital in the final goods sector. Okay, but also have in mind that a higher alpha given or holding constant beta means more market power for each intermediate good producer, for each monopolistic firm in the intermediate good sector. Okay, what we see is for any given, you see here the function or the effect on growth that comes from this fraction from the previous equation for 3 different types of beta. Okay, so if we hold beta constant, so if we follow any of those 3 lines to the right, that means for any beta, we're increasing the marginal return to human capital in the final goods sector. This will lead to a decrease in the growth rate. Where does that come from? It comes from the fact that if the marginal return to human capital is higher in the final goods sector, more human capital skilled workers will want to work there, therefore making them more expensive in the research and development sector. Okay, so a higher alpha pulls away resources, the main or one of the main resources, human capital, from the research and development sector. That's why it's so important in the model that 2 sectors are competing over human capital. There's a second very interesting story in that graph. So far, we have seen if we increase alpha, leaving beta constant, then growth will decline. That means an increase in intermediate goods firms' market power will decelerate growth. Okay, does that mean that increasing market power of these firms will always decrease growth? No. How can we see that? We can keep alpha constant and can look at an increase in market power that comes from beta. Okay, so if we so let's say we're at an alpha of 0.15 and we're moving from beta is equal to 0.1 to a higher beta. What does that mean? That means more market power for intermediate goods monopoly firms. Okay, what do we see? More market power will here increase the growth rate. Okay, whereas if we do the same trick and start with the blue line here at an alpha of 0.35 say and move to more market power to the gray line, for example, we see that growth would decelerate. And this is this very interesting implication of the Roma model with respect to market power. If market power is already high, a further increase in market power will be counterproductive to growth.
if market power is low, then an increase in market power will increase the growth rate because it makes it more profitable for firms to invest in designs and research and development.
Okay, I hope this has been helpful to you, and maybe you get an idea now also what implications the model has. Besides from the production function in the research and development sector that I've already mentioned and the role of market power, I want to give two more examples. One of them is the role of international trade. Okay, so what would trade intuitively do in the model? We have in the intermediate goods sector fixed costs, but with trade we would have a larger market. That means we can bring down the average costs per unit of the intermediate good. Okay, so that should also lead to more capital deepening, which means more different types of intermediate capital goods. Okay, that's why the model would predict that trade, which basically is the integration of two different economies into one joint economy, should increase the growth rate and the output level. Okay. The other intuition you might get is, of course, that the design of patents and property rights for intellectual developments is very key to the model. Okay. So the model is very rich also in its nature, and that means it can accommodate different empirical findings. For example, we might see convergence as well as divergence between countries, okay? And we might even see cases of zero growth, because if human capital is too low, the economy will be in a stagnation phase. But this is also the problem of the whole model. It provides a wide range of possible predictions depending on the underlying assumptions about the parameters, but that also means that we cannot give very clear testable hypotheses that we can bring to the data. Nevertheless, Romer's endogenous growth model from 1990 has been a major intellectual achievement, because all of that goes on in one general equilibrium model that also has a micro-founded structure, so where households maximize their utilities and firms maximize profits. And that has been a major achievement in the 1980s that Romer worked on for almost a decade. Okay. So I hope this short clip helped you to understand a bit what's the key intuition of Romer's model. And if you still have any questions or comments, you're always welcome to post them below the video in the comments.